Hello students, how are you all? Hope all of you are well. This is the second lecture of organic chemistry. In the first lecture, we have discussed about alkane, alkene, alkyne, alkyls group, hybridizations, and the geometry of the carbonic compounds. In this video, we'll start with the last thing, whatever we have done in the first video. Here I am going to just tell you about the hybridization in organic compounds. What are the hybridization in organic compounds? As I have said you, for sp means single bond, double bond, triple bond. I hope all of you have remembered about the first lecture. In the first lecture, I have said you that carbon-carbon single bond means alkane, double bond means alkene, and triple bond means alkyne. So here, dear students, for single bonds sp3, for double bonds sp2, and for triple bonds sp hybridization. Now here you have to understand how many p orbitals have been used and how many p orbitals has not been used in alkane, alkene, and alkyne. So dear students, in sp3, in single bonds, all the 3 p orbitals has been used. In double bonds, 1 p orbital is still left. You know very well that p orbitals have 3 orientation: px, py, and pz. In single bond, all the 3 orientations have been used. In double bonds, only 2 orientations of p orbital has been used, and in triple bond, only and only just let you say that triple bonds and double bonds here are just 1 and 0, 1 and 2. These are the unused p orbitals. Means all the 3 have been used, 2 have been used, and only 1 has been used. So here are the number which are indicating p to the power, like sp3, sp2, sp, means this p orbitals have been used and rest p orbital has not been used. So unused p orbital 0, unused p orbitals 1, unused p orbitals 2. Now I am telling you about the bond between the carbon, hydrogen, sigma, and pi. So here all the 4 bonds will be sigma bonds between all the sp3 hybridizations, and sp2 3 sigma and 1 pi will be there, and sp hybridizations 2 sigma and 2 pi bonds will be there. The geometry of sp3 is tetrahedral, the geometry of sp2 is trigonal planar, and the geometry of linear. Geometry of 180 degree, that's linear. The bond angle between sp3 109 degree and 5 minutes, for sp2 120 degree, and for sp 180 degree. So trigonal planar, linear, trigonal planar 120 degree and linear 180 degree, and tetrahedral has bond angle of 109 degree and 5 minutes. If we talk about the S character, so here already has been indicated that S character means all the 3 orbitals of p orbital have been used. So 75% there is a character of p and 25% there is a character of S in sp3. And if we talk about sp2, then if we talk about sp2 means the 33.33 percentage, because here 100 we are dividing by 3. So 100 divided by 3 means 33.3333 recurring. So 33% S is being used and rest P is being used. And if we talk about sp hybridization, so 50% S character is there because 50% S orbital is being used in triple bond and 50% for other. So here S character we talk about in all the tetrahedral, trigonal planar, and linear. So in tetrahedral 25%, in trigonal planar 33.33%, and in linear it's only 50%. Means more it is in triple bond, not in double and single bonds. Now let's come to the point of bond length. So here there will be 2 types of bond length. One between the carbon to carbon, and another will be between carbon and hydrogen. So between carbon and carbon in single bonds it's 154 picometer, or you can say 1.54 angstrom. You know very well angstrom and picometer. 1 angstrom is equal to 10 to the power minus 10 meter, and 1 picometer is equal to 10 to the power minus 12 meter. So that's why I said you 154 picometer between single bond, means sp3 hybridizations will have 154 picometer, sp2 hybridization 134 picometer, and sp hybridization 120 picometer. Carbon hydrogen in sp3, so here carbon hydrogen will have 111 picometer, 110 picometer, and 110. Or if you go through the 4 digits, so here you can change it to the picometer. So 111.2 picometer, 110.3 picometer, 110.8 picometers will be the bond length between the carbon and hydrogen atom. Now let's talk about one enthalpy. So there will be two enthalpy in very well. The carbon-carbon and carbon-hydrogen. So carbon-carbon, if we talk about in sp3 hybridization, 80 to 90 kilocalorie per mole. If we talk about sp2, 120 to 164 kilocalorie per mole. If we talk about sp3, 123 to 199 kilocalorie per mole. Similarly, for carbon and hydrogen atom, 104 kilocalorie per mole for carbon hydrogen in sp3, 106 kilocalorie per mole for sp2 hybridization, and carbon hydrogen, and 121 kilocalorie mole for carbon hydrogen in triple bond, that's sp hybridization. So these are the hybridizations of this organic chemistry. Now let's come the classifications of organic chemistry. Classifications of organic compounds. Organic compounds have been classified into two parts. One, that is open chain structure. Open chain structure. Another is closed chain structure. Closed chain structure. You can say them as a ring structure, ring compound, or you can say cyclic compounds or cyclic structure. And here open chain structures is also known as acyclic structure. So these are the classifications of organic compounds. So if we talk about the open chain structure, there are two. One is saturated and another is unsaturated. Similarly here, homo and hetero. Homo and hetero means two types of this organic compounds are there. Classifications of organic compounds have been done by the two methods, one by the open chain structure and another one by the closed chain structure. If it is in the closed part, it's known as cyclic or ring, or you can say them as a closed chain. And if they are open or cyclic, you can say instead of cyclic, you can use the word or cyclic, and it is saturated and unsaturated, here homo and hetero, closed chain structures. Now you will have a question in mind. So the saturated, which I have taught you in lecture 1, alkanes, and this unsaturated, alkenes and alkynes. What about this homo and hetero? Homo and hetero. Now here you will have, there are two types of homo and hetero also. One you may have heard about, closed chain structure, means it is any structure which are closed between the two carbon, there will be having a single bonds. Single bonds means you can use them as a cyclopropane, cyclobutane, cyclohexane, cyclopentane, cycloheptane, cyclooctane, any cyclo word you can use for homo. Homo means what? Carbon is having a single bond. If I talk about the double bond and triple bond, then you may be confused that sir I have taught something else and now it's being something else. Right? So no need to worry, dear students. Everywhere carbon is there, everywhere single bond is there. Sometimes it can be double bond also, and it can become benzenoid and non-benzenoid. So first of all, understand about the cyclic structures, and another which are the heterocyclic structure. Homo means everywhere carbon will be there, and hetero means except carbon. Just suppose here I have put here N, I have just made few bonds also, just like benzene. So its name, if you talk about this carbon name, which is hetero, means heterocyclic compounds, then its name is pyridine. Instead of carbon, pyridine means if anybody will ask you what is its chemical formula, C6H5M. So what I have done here, everywhere there was a carbon containing compounds, there was a HOMO, and we have removed one carbon and replaced with another element, then that compound is known as hetero. So remember these words, HOMO and hetero. It can be furan also, it can be another things also, pyridine, pyrrole. Okay, so these are the few. Now we'll do the classification based on the functional group. I'll make one table and I'll show you the table that how to remember the names of these classifications, functional groups. I hope that you will remember it very easily. It's not so hard. So dear students, these are the classifications of functional groups. Means I have written here the classifications of functional groups. You can see on the board that one to one each and every compound I have mentioned. The first compound which I have mentioned is olefins, and you can see here the double bond between them, and they are having two double bonds. So it's known as alkenes. Alkenes double bond, as we have seen, olefins, alkenes. If we talk about the triple bonds, it's known as alkynes, and general word it's known as acetylene also. So we generally say about ethyne as a acetylene. If we talk about alkyl halides, halogen group, fluoro, chloro, bromo, it's known as halo. Alcohols, you can see the functional group OH, as hydroxy also it's been used. Ether, ROR, CH3OCH3, so it's known as alkoxy group. If we talk about aldehydes, RCHO, it's known as aldehydic group. Ketones, RC double bond OR, it's also known as ketonic group. If we talk about the carboxylic acid, RCOOH, so it's known as carboxyl group. So the functional group which I have divided and I have written the names of the functional groups, that what they are generally known as. Acid halides. Acid halides is also known as acyl halides. Remember the word acid halides, acyl halides. RC double bond OX. Here X means halogen. Fluoro, chloro, bromo, iodo. If we talk about amides group, RC double bond NH2. It's also known as amide group. RC double bond NH2, amide group. Acid anhydride, RC double bond O, single bond O, RC double bond O, and then R. It's known as anhydride group. If we talk about esters, RCOOR. So here RC double bond O, CH3. So I have given here it's ester groups. If we talk about cyanides and nitriles, so remember RC triple bond N. This is called cyano. But if you talk about here isocyano, then remember single bond nitrogen, double bond with carbon, and carbon attached its lone pair electrons, that's make it triple bond, and it becomes isocyano. If nitro compounds, nitrogen generally have 3 bonds. So you can see the 2 bonds with first oxygen and another is a single bond, but the next oxygen is attached with a lone pair of electrons of nitrogen, so it becomes nitro group. Last one is amines group, so NH2 group. So this was the basic video of the classifications of functional group. What are their name known as? These all the things will be very useful in class 12 year students. Most of the students do not know what is anhydride. They come in class 12, they don't learn in class 11. So these words are very useful for class 12 board examination. Don't forget this classifications of functional group. That's all for today. Take a screenshot as I move from this video. Don't forget to write this all the classifications and functional group and their names, because these names are very important. It may be useful in class 12 board, even in NEET and JEE also. So dear students, take a screenshot, and that's all for today. Thank you very much. Have a great day. Don't forget to like and subscribe the channel. Share this video with your friends. Bye bye and take care. Chappa khair.